Hi everyone! In my last video, I talked about motor control and the easiest way to get the motor up and running. Today, I'll be talking about some best practices. Basically, these are some behaviors you should adopt if you're looking to get the most life out of your motors. Believe it or not, motors are actually incredibly fragile. Feed too much power into them and they will break. Place a load that is way too heavy on them and they will break. Running them way too hard and getting them incredibly hot will melt the insides. I can go on. Because of things like this, there are things you can do to regularly maximize your motor's lifetime. Here are some of them. The first thing you can do is to make sure that your motor doesn't smell when you run it. What? Are you serious? Yeah, that smells ozone. You don't want to be smelling it because it means that you're damaging your motor either by giving it too much power or having it lift something it cannot. This might sound silly, but I've gone through enough motors to know that if something smells, something's up. In a related note, if you see gray smoke coming out of your motor, you've let the genie out of the bottle. You broke your motor. It's also gonna smell. The second thing you can do is to not backdrive your motors. What's that? It's when you attach a weight to your motor with the power off and the motor just sorta sags when the motor needs to stand on its own. Basically, the static non-powered torque of the motor is not enough to hold up the weight of the load. Even if the motors run fine with powered, you really don't want this happening. By letting the motor continue to strain while powered, you will eventually wear them out. The third thing you can do is to place fans near the running motor to reduce heat. The biggest culprit in broken motors is heat. A high enough internal temperature will melt the metal coils inside and short-circuit the insides, causing the motor to break. The fourth thing is to avoid a motor stall condition. What's that? It's when a motor is running and trying to move a load, but failing miserably. Symptoms include lots of jarring noise, a hot motor, and a non-moving motor axle. Continue this state for a long time and you will most certainly break your motor as it rapidly heats up and breaks. The last thing you can do is to make sure that the power source you connect to the motor does not exceed the motor's voltage rating. If you do this, the motor may run, but it will fail over time. The issue here is heat. Running a motor with a voltage higher than the voltage listed on the spec sheet means that the extra voltage will be dissipated as heat. With repeated heatings, the motor will start performing poorly and over time, fail. Too much heat at once and the motor immediately melts inside, causing it to fail. The greater the positive difference in power, the greater the damage. And that's all the basic information you will need to use and understand motors. I highly suggest that you go out, buy some stuff, and try using motors. Everything here is theory and bits of my personal experience, but the best way to understand motors is to actually go out and try to use them. I enjoyed sharing this information with you, and I hope that you will put it to good use. Let me know if this is useful for you.